morning, students. I hope everyone is doing well. I haven't seen, I might not have seen some of you since Thanksgiving. So I hope you guys enjoyed that break. Only two science classes left, including today. So there's only one more after today. So we're going to get all of our science in, right? We are going to be talking about fire today, um, as your agenda says. Um, we talked last time about indigenous populations and how they deal with climate change and how they treat the ecology of their surroundings and how they are essentially one with the earth and the earth cycles, right? Because they've gotten so used to the cycles, they are in a much better place to kind of not only judge but prepare for climate change as it happens. So, what we're going to look at today is when some of those things we can't really control. And one of those things is fire, right? And fire happens to be something that is currently plaguing the west coast of this country. Even today, the states of California and Nevada are on fire, right? There are wildfires that those folks are currently dealing with, and something that they have to contend with on a regular basis. I don't know if anybody got a chance to do this activity here where I asked you to Google the Santa Ana winds and kind of like look at one of the articles that come up. But if you were able to do that and you Googled Santa Ana winds, and if not, I can do it for you right now and I'll just show you how that works, right? But I just look at Santa Ana winds, right? And I'm going to Google it. So I'm going to share my Google. Just going to put it in Google here. I'm going to Google Santa Ana winds, and we'll see that there's a bunch of news stories that come up. And this first one is about the wildfires, right? So California wildfires erupt amid strong Santa Ana winds that could last into next week, right? And this article is from 16 hours ago, so it's a very recent article. But the idea here is that because the winds have gotten so strong, right? The winds have been able to ignite um, fires in California, right? So the winds have been getting up to 95 miles per hour, right? And so they've been forcing thousands of people to leave their home. One of the problematic things about this, of course, is like, not only are fires destructive and dangerous, but in California, they are currently under a new stay at home order because of how the coronavirus has gotten out of control. So these people are dealing with this fire and then being asked to evacuate their home. And where are they really supposed to go, right? So it's a really tough situation that these people are currently in, given what's happening, right? And so it's really interesting um, what they currently have to go through. But fires are a pretty destructive force, and the way that our climate is changing, that because the Earth is becoming warmer and drier in certain places, it means that these fires are going to become more prevalent and more destructive, right? And so California has been dealing with this for a while now, but it seems that even more have picked up recently, right? So um, you know, think about that and think about like what these people are currently going through, and then we're gonna think about how we are currently dealing with wildfires, what wildfires kind of how wildfires are caused by climate change. We're going to learn a little bit more about that, and we're going to do some thinking about kind of why fires are so fascinating and how fires um, are something that we've had to deal with as people for a long time. Okay, so that's what the plan is for today. I'm going to pull up the Schoology course. I'm going to go to Schoology, and in your Science 3 course, right, we are working in the week 11 folder, Humans and Fire. It has today's date on it, December 4th. So we're going to open up that folder, all right? Um, And we're going to start off with this discussion here. It says humans are part of Earth's natural system. Good morning. Humans are part of Earth's natural system, so our actions are part of Earth's natural system. So I just have that statement here. You can answer it in Schoology, you can answer it in the chat. But what do you think about this statement? Do you agree with it or disagree, and why? So again, it says humans are part of Earth's natural system. So our actions are part of Earth's natural system. Do you agree or disagree, and why? So again, you can answer it in Schoology or in the chat, but I would like to give you just guys a couple of minutes to just think about this statement and how you would respond. All right, so what do you guys think? Humans are part of Earth's natural system, so our actions are part of Earth's natural system. Do you agree or disagree, and why? I don't see any comments yet. Did I miss anything in the chat? Oh yes, let me see. There's something in the chat. Yes. Why? Because whatever we do as humans, we contribute to the Earth's natural system, good or bad. Okay. All right. Let me just put that into the chat and the comments. Anybody else? Any other thoughts? Humans are part of Earth's natural system, so our actions are part of Earth's natural system. What about the idea that we're not really natural, that we're kind of supernatural? There's no other animal on Earth kind of like us. We're very different. What about that idea? How does that play in? Right, we're the only ones that like are using a lot of the Earth's resources to build our homes and then to make technology and other things. Okay, all right. I see. Comments. I'm going to put that in here as well. All right. So humans are part of Earth's natural system, so our actions are part of Earth's natural system. All right, so good or bad, we are part of Earth's natural system. Okay. All right, so let's kind of explore that a little bit more. I'm going to go back into the week 11 folder. And I'm going to open up we're going to watch a little video. All right, we're going to watch this video and then we're going to respond here in the comments about what do we think causes wildfires? And what else do you notice about the video? So we're going to watch the video. We might watch it a couple times. And then I'm going to ask you guys to kind of comment on what do you think the cause of wildfires are? And what else did you notice about the video? So pay attention because I just want to like have a commentary in general about what's happening in this video.
You can't deny the fact that we're losing millions of acres and trees. The more pine beetle kill there is, the more dead trees there are. The more dead trees there are, the more logs there are to feed the fire. It was really sad for all of us. I had a few friends that lived up here. They lost their houses to their fires. They lost their pets. They lost everything. This is whatever's left of my friend Nikki's house. It's really sad because it's hard to believe that this was ever a house. It was definitely something that affected all of us in some way. It changed people's lives forever. It's happening now. This is happening here, and this is real.
All right, so I'm going to do it one more time. It's just a 51-second video. I'm going to play it one more time, then we're going to answer these questions here.
You can't deny the fact that we are losing millions of acres and trees. The more pine beetle kill there is, the more dead trees there are. The more dead trees there are, the more logs there are to feed the fire. It was really sad for all of us. I had a few friends that lived up here. They lost their houses to their fires, they lost their pets, they lost everything. This is whatever's left of my friend Nikki's house. It's really sad because it's hard to believe that this was ever a house. It was definitely something that affected all of us in some way, changed people's lives forever. This is happening now, this is happening here, and this is real.
Okay, so that was that quick little video. So what did you see as the cause of wildfires in the video? What did he mention was a cause of the wildfires? What caused them? Why did the wildfires start happening?
You said pine beets or beetles.
Mm-hmm. Yeah, pine beetles, right? He mentioned that pine beetles. So it was this, there's a bug apparently, a pine beetle, that is responsible for the cause of the wildfire. I'm sorry?
He said dead bees.
Mm-hmm.
Beet.
So the pine beetles are killing the trees, right? Yeah. So that's as Toya just said, right? The pine beetles are killing the trees, which is what is fueling the fires, right? As there are more dead trees, the fires spread more easily, right? So there's a connection here. So the pine beetles are destroying the trees. As the trees are destroyed and die, they're kind of just there for the fires to eat them up, right? And so that's how the fire spreads more easily. Okay. Okay, what else did you notice in the video? Was there anything else that drew your attention?
Sorry, Mr. Grassano, sorry, I'm late.
Oh, no worries, Jennifer, it's okay.
I had my in-laws around, so I was trying to put something in the oven for the afternoon. I'm so sorry.
No worries, those in-laws, I'll tell you. So what did you notice about the video? Was there anything that drew your attention about the video? Any of you? Is there anything that was interesting to you about what was happening? Go ahead. I'm sorry, I didn't hear that.
Abandonment. I noticed the area was abandoned.
Okay, yeah, the area was abandoned. Okay. Abandoned area. It's spelled abandoned today.
I didn't watch the video.
It's 51 seconds, so we can play it again. Okay, but it was abandoned. So what? So I want you to notice just some things about this video for me. Like whatever you notice, whatever stands out.
You can't deny the fact that we are losing millions of acres and trees. The more pine beetle kill there is, the more dead trees there are. The more dead trees there are, the more logs there are to feed the fire. It was really sad for all of us. I had a few friends that lived up here. They lost their houses to their fires, they lost their pets, they lost everything. This is whatever's left of my friend Nikki's house. It's really sad because it's hard to believe that this was ever a house. It was definitely something that affected all of us in some way, changed people's lives forever. It's happening now, this is happening here, and this is real.
Okay, what else did you notice?
There was a lot of mountains, Mr. G.
Okay. You noticed that there were mountains in the video, okay. Where was this, where did this take place?
California.
California?
Yes.
Colorado.
Colorado, right.
Oh, Colorado, okay, yes. All right, so it was in Colorado. Anything else drew your attention about the video?
Okay, is it about the destruction? Like houses were destroyed.
Houses were destroyed, okay.
There was a lot of trees.
Mm-hmm.
It looked cold, and I saw no trace of
Hot
wildlife.
lakes.
Good. Okay. Trees. Love it. It looked cold, no wildlife. Right. Yeah, so that's very interesting, right? So that's part of what some of the things that I noticed too, right? So we talk a lot about California because California can get very warm and very hot, right? But we're talking about Colorado, which isn't known to get very hot. It can during the summers, but it's normally a very cold state. So you have to think about how extreme the weather had to have been for there to have been a wildfire to begin with, right? And then the idea that these pine beetles are what destroyed the trees and then allowed for this fire to kind of spread the way that it did. So there was a natural source, right, of this destruction, right? These pine beetles are natural, right? Nobody like put them there. So that's part of nature. They were there, right? But they were there in such an abundance and at a time when the temperature got very hot. So then it was just those two things colliding helped to cause this wildfire, right? And not only were people displaced, right? And notice that the people abandoned the area right after this fire, but as it was just pointed out, there were no animals either, right? All the wildlife is also gone. That's something that's also really interesting too, right? Is that when we think about climate change and how it affects, we really just think about the people, right? But the effects on other parts of our environment, the ecosystem, the animals, are just as important, right? Because we, especially people are feeding on those animals or need those animals for certain things, that wildlife is now gone or displaced because their homes are destroyed as well. Okay. Anything else that you guys noticed in the video?
Was there a lake, Mr. G?
I didn't notice a lake. Did anybody else notice a lake? I didn't notice a lake.
I did notice the snow, which may lead to snow melting.
Okay.
And also, I noticed that it also could be a way of self-rejuvenation because like my family, we burn brush when it gets overwhelming. We gather it and burn it. So it may look negative that it naturally caught on fire, but it may be self-healing in a way. In a couple of,
Yeah, so that's very good. And that's a good observation. There are some trees and other kinds of shrubbery that the only way for the new growth to happen is for the old growth to burn down, right? So some trees like have very sturdy seeds, and so they'll drop these seeds and these seedlings, but they won't grow until after a fire because they know that the other older trees have been wiped out, right? And they can now have access to the sun, right? So some trees actually need that. Some trees and shrubbery actually need that wiping out, that cleansing that was just mentioned, right? In order for that new growth to happen. So some fires are natural, right? It's when they become out of control and spread into this unwieldy kind of thing. That's when we're looking at what we call like a wildfire or something that is more destructive and could be a result of climate change. Okay, good. I like that. Anything else? Anything else you guys noticed about the video? Who narrated the video? Who was this person talking? Who was this?
A child.
A child. That didn't draw anybody else's attention?
Yeah,
I was very drawn to that, right? This idea that like, here's this kid, right, who's reflecting on how much his life has changed as a result of these fires. I think we often have to listen to scientists and talk about their stories and about what needs to be changed and what's done. But I think what makes something more impactful is when we look at the real people and how they become affected by things. And so this child, I think sharing his story, makes it something that you engage with better, right? So I just think of like how much more impactful it is to see a child discussing these issues, right? So anyway. Yeah.
I was even wondering, I said, why is it a child making the documentary?
I think it's because, he got interested because his friends lost their home in it.
Right.
So that's what intrigued him to really do the documentary.
Absolutely.
Because if you notice, he said this was the home of one of his friends.
Yep. Mm-hmm. Yeah.
And when you talk about the pine, are the pines the trees?
Yeah, so those are the kinds of trees. So a pine is a kind of tree, and it's a very popular kind of tree, right? It's the ones that have the spikes.
Yeah, that makes noise, right? That's like sings when this we're like.
Oh, absolutely. Yeah, that's true. It does. Yeah, and they produce the cones, right? The pine cones.
Yeah, yeah, the pine cones. Okay.
Yeah, so those are pine trees. Those are the ones that are evergreen, right? They're always green. They don't ever lose their leaves or needles, right? Yeah. Okay. Good, good, good.
And the bee are called pine beetles because they're fine where the pine trees are.
Correct. Yeah, they feed on pine trees, right? So that's why they're called pine beetles. Exactly.
Oh, okay.
Yeah, certain beetles feed on certain plants, just like you know, people who've grown up around harvesting know that like certain beetles or bugs are associated with different kinds of plants. Like, you know, to expect a certain kind of bug in your flower, right? It's like, oh, that's natural, right? Because that happens during the harvest time. You're gonna end up with a couple bugs, right? You know, so beetles and certain bugs of that nature will they have certain plants that they feed on, and this happens to be a pine beetle feeds on pine trees. Yep. Okay, very good. All right, so we're going to take a look at our next item, which is actually going to be practice number 1. We're going to do a couple activities together. We're going to make sure we understand some vocabulary, and we're going to read something about how fire, like these wildfires and climate change, are associated. All right, and so yeah, we're going to take a look at that right now. Give me a second. I have to pull something up to help us with that.
All my life you have.
Okay, so here is just some information here that was shared about wildfires, the years that they happened, and how many millions of acres of land were burned as a result of wildfires. So the years go from 1983 to 2015. What do you guys see? Is there anything you see or notice or wonder? Any questions you have as you look at this table and try to digest some of this information?
In 1991, the most was burned. It was 7.2, that the highest. No, 1993 had the highest, sorry.
So if you
2004.
Yeah, so when you're looking at this today, yeah, this is a little bit of a difficult table to read, Miriam. So like we have the year.
It's 2004, sorry.
Yeah, so you have the year, and then next to it you have the millions of acres, and then you have years again, and then next to that, so you have to keep going. So the table keeps going. So
even in 2015, 10 acres,
like
the highest.
Yeah, so 2015 seems to have been the most. Yeah.
Right.
Anything else that you notice? It's a pretty difficult table to read.
So in 1993 and 1995, both year at 1.8.
Okay, yeah, that's true. And that's pretty low, right? Considering some of the other years, right?
And also 1989, it's 3 of them, 1989, 1993, and 1995 at 1.8.
Okay, yeah, interesting. Yeah, that's very true. Yeah. It seems to like...
We noticed that in it's from 2000, I noticed that in 2015, from 2005, down to 2015 is much more, is higher.
Yeah.
Even 94 to 2004 is higher than the previous years. Like it's, coming up more in the 2019 to 2015. 1994 to 2015. I mean, it's really,
it's a lot more, right? Yeah. Okay. So yeah, if we look at it like even in 10-year periods, right? Because every block is about 10 years. If we look at it in the blocks, in this first 10-year period, right? The worst was 5 million acres, right? That was the worst in 1988. And then some of the other years are, 1, 2 million. That comparatively looks a lot less, right? In that 10-year block, the worst is 5. If you go to the next 10-year block, right? The worst is now up a lot higher, right? We're now up to 8.1, right? From the worst being 5, the worst is now 8.1, right? And you have a lot more years that are pretty close to 8.1, right? In that previous 10 years, you had this 5.0 and you had 4.6. Those were the only two that were even that high, right? So there weren't a lot of high marks. And then you get to this next 10-year block and suddenly we're getting a lot higher. There's a lot more people trying to get close to this 8.1, right? There's a lot of competition for who's the worst. But then you get to this final 10-year block and it's like, whoa, right? Because you have 10.1, you have 9.9, you have 9.3, you have 9.3 again. There's a lot more millions of acres being burned, right? So what do you think this is telling us?
That is getting worse.
Yeah.
It's like it's getting worse
in general, right?
Yeah, in general, yeah.
In general, it's getting worse, right? It's getting worse. The more and more wildfires are definitely happening, right? Okay. All right, we're gonna look at a little bit more data. I love looking at data.
Also, I noticed if you look at the data from the 10-year to the 20-year range, like 1983 to say 2013, it still increases, but it doesn't show the dramatic increase like in the 5 to 10-year interval. So in 20 years, it make it look like it's increasing, but not as rapidly.
Okay, yeah, that's very true. Yeah, if I go from 83 to 2003, right, that's about a 20-year period here. Like 1.3 to 4. You're like, oh, I mean, that's fine. That's okay. That's not drastic, right? Same thing if I do 2003 to 2013, even that's a 10-year period, so not even 20. Like, oh, it's 4.0 to 4. If I don't have to, if I don't look at all of the data, but I just look at every 10 years, I might be like, oh, that's not a big deal, right? I kind of have to see all of the numbers together to get a really good impact of what's happening. If I selectively choose this data, I'm like, let's just go with all the 3 years. If I just look at 1983, 1.3, 1993, 1.8, 2003, 4.0, I was like, okay, that was a big jump, right? But it doesn't tell me the story of 2004. It doesn't tell me the 8.1. It doesn't tell me the 1999 of 5.6. It doesn't tell me the 6.1 of 1996. And then I go 10 more years and I go to 2013, I'm at 4.3. And I'm like, oh, again, it's not increasing that much. If I could tell a very selective story, right? If I just choose certain years in a certain way, I'd be like, oh, see, it's not that bad. It's not as bad as people say it is.
Yeah, you could alter some studies.
Yeah, and alter some perceptions, right? Because if you show that to people, be like, look at these years. Like for every 10 years, the increase is not as big as people are saying it is. You're just like, oh, well, I guess that's right. But you don't see the whole picture, so you don't really know. Yeah, it's very true. Very true. Good observation. Okay, so we also have, and this is from practice number 1. So I already opened up practice number 1 in this other tab here. So there is, if you open it with Cami and you open up that PDF, you'll get to a graph that looks like this. All right. And in this graph, it tells us the amount of acres again that was burned, and then it also tells us the temperature increase, all right? So it'll tell us the increase in temperature versus the acre of lands burned, all right? So what we'll see here is this, the number of acres are going to be measured, and this is what is called a double axis graph, where you're measuring two things along the y-axis on the left and on the right. So it's a little bit confusing, but both things are increasing, right? Essentially, you have what you're measuring is the number of acres of land burning, as well as the temperature increasing, right? And you're just like saying how much it increased over the previous year, more or less. Okay, and so this is what we're looking at, and you can see that there's sometimes it goes down, sometimes it goes up, but essentially as the temperature is rising, so are the number of acres of land that is burning. If the temperature has dipped down, the acres of land that have burned have also dipped down, all right? And so there is a little bit of a trend here going on to kind of demonstrate to us that as we get warmer, more or less, the number of acres of land there are more acres of land that are going to burn. All right, so we're gonna take a look at some of this.
Sorry, there's a question I want to ask, like the temperature.
Yeah.
And the acres of land. Mm-hmm. Like now, there is a sign to know the temperature. Where is it? How do we know the temperature and then the acres of land?
Okay, so on the left axis, so still on the y-axis, so you're looking at the vertical numbers, right? So as it goes up, I will plot where my acres of land are, right? I'm also plotting at the same time. This is what makes this graph a little bit challenging, is I'm also graphing whether or not there was a change in temperature from the previous year. And notice the change in temperature can be anything from a negative number, like it could have gotten cooler, to a positive number, but it's only a range of 4.5, right? Because it can go down to -1 or up to +5. The temperature is relatively stable, but it has about a 5-degree difference. So if, for instance, in 1985, right, only less than 1 million acres burned, right? And the temperature was about almost a full degree lower than the previous year, right? And I can tell that because of where I graphed my information, right? I'm saying that as my temperature was lower, the acres that burned were also less, right? And that's how that corresponds. If I go to the right, I can see where the temperature was. And as I go to the left, I can see how many millions of acres burned, because it's going to tell me that on the left side, tell me the temperature on the right. I don't know the exact temperature. I just know that it was less than the previous year. Okay, so you're making kind of a judgment call here. Additionally, when you go up here to the next year that's plotted, which I assume is going to be 1986, I can see that more acres of land burned, right? And also my temperature was about 2 degrees higher. Why was it 2 degrees higher? Because it was negative before, and now it's over +1. So that's how I know the temperature went up. All right, so I'm plotting both of those things when I plot on this double line graph here, this double axis graph. But yeah, so this is how that sort of works.
Okay, try.
Okay, yeah. All right. So we're going to try to read this graph today. This is going to be our big challenge for today, is to try to understand how to read this graph. And why we're doing this is because this is essentially what it is like to prepare for the science exam, is really to do an analysis of graphs and charts and other things that you're being shown, okay? This is going to be one of the most complicated graphs you'll ever have to see, and hopefully you won't actually have to do a lot of work like this, but it's just good to get the practice in, right? So we're going to try to figure out the variables when we're looking at a graph that looks like this. All right, so give me a second here. I'm going to make sure we can scroll down and see the questions. Okay, 1 second. All right, so we have this graph. And the first question they're asking you is, there are 3 variables in this double y-axis graph. What are the dependent and independent variables? When you look at a graph, how do you know where the dependent and independent variables are? Right, that's just a basic question. Anybody know where to identify your dependent and independent variables on a graph?
When you say dependent and independent, I got confused.
Okay. All right, so we'll talk about that. But anybody know where I can identify the dependent and independent variables on a graph before I get to Jennifer's question?
Mr. G, would it be over where the 0 is and over where the 1.0 is?
Essentially. So what I'm asking you is, there are two things normally on a graph, right? You have your horizontal axis and your vertical axis, right? Normally. In this case, we have 2 things on the vertical axis and 1 horizontal. What I'm asking is, where is the dependent? Is it on the horizontal or is it on the vertical? And where's the independent? Is it on the horizontal or is it on the vertical? And I saw that somebody wrote something in the chat. I'm hoping it's Toya, because she should know. Yes, Toya, X and Y axis, but which one is which? Which one is dependent? Which one is independent? You should know, because we had
Mr. G,
this in class.
Is the downward? Is the
Go ahead, Miriam, were you saying something?
I was saying the X would be the side from the 0 to 12, and the Y would be the side from 1985 to 2015.
Other way. Right? Your Y is always vertical. All right, so let me draw it in. We're gonna do, we're gonna learn some. This is gonna be good. This is some critical math things in science class. I love it. All right. I love talking graphs. Okay, and data. That's my happy place. Okay, so when you look at a graph, okay, you're always going to have things along what is called the vertical line, which is the vertical axis. This is known as your y-axis. Okay, vertical is y, and along your horizontal axis, which is down here, is your x-axis. Okay. All right, in this special graph, we actually have 2 y-axes, right? The left here and the right, but just so you know, this is not normal, okay? This is an abnormal graph. You're normally not gonna have 2 things on the y-axis, but this is also another y-axis. Any vertical axis is the y, any horizontal is the x. All right, and I think Toya may have answered my question here in the, yay! Okay. She probably had to pull out her notes from this week, but that's good. All right. Whenever you are looking at something that is along the y-axis, that is your dependent variable. That means that it is dependent, or it's going to be a result of whatever is happening on the x or independent axis, right? The independent axis is the new information that you're finding out, and the dependent axis is a result of that information. It's what we're measuring, okay? So on the x-axis, we have the years, right? The years are independent. I can't control that how my years change or how calendars work, right? They're independent. So I'm measuring the years because along the x-axis because they are independent. But every year I get new data that I now have to graph on my dependent axes, my 2 y-axes. So on the x-axis or along the horizontal axis, you always have your independent variable. Okay, this is independent. All right, and your y-axis is always where the dependent variable is. Okay, so your y-axis is always dependent. In this case, we have two dependent variables. Again, this is not normal, but in this special case, there are two dependent variables. All right, so when we answer this question down here, which I'm going to scroll down to in a second, just so we can see it again, we're going to identify that there are three variables in this double y-axis graph. What are the dependent and independent variables? So my independent variable is the year, right? And then the two things that are along my sides are going to be my independent variable. I'm going to write it in here using my Kami app. I'm going to write that my dependent variable is the year. Okay, and my independent variables are the land burned, however you want to summarize it, because I don't want to write acres of land burned, million acres. That's too much. So I'm going to say the land burn and
the temperature.
Exactly. All right, so those are my dependent and independent variable. Okay, so as confusing as this might be, especially to people who are brand new to it like you all, what would be an advantage to using a graph like this? It has two independent variables. It has two y-axes, right? So what is one advantage of using the double y-axis graph? You guys can just kind of think about it, you can think out loud about it. Again, I know this is your first experience with it, so it doesn't have to be a perfect answer, but just as you look at it, what could be an advantage?
You'd be able to get more data.
Yeah, right. I mean, so basically what you're able to do is you're able to compare two dependent variables to one independent variable. Okay. You can compare two dependent variables to one independent variable. Good. All right. Our next question down here says, in what 3 years did the US experience the largest temperature anomaly above normal since 1983? All right, so let's answer that part of the question first. We're going to use the graph. So again, I'm going to read it. In what 3 years did the US experience the largest temperature anomaly above normal since 1983? So in what 3 years was it the highest temperature, essentially?
Maybe 2013.
Okay, 2013, good. What other?
In
2015 and 2014. No, 15.
Yep, third. Okay, so 2000. It looks like actually this is 2012, right? Yeah, 2012, right? 13, 14, 15. Yeah, this is 2012. Okay, 2015. Good. What else?
2006.
And 2000.
Yeah, 2006.
Good. Yeah, it seems like 6 is a little bit
6,
higher.
7. Yeah.
6. Yeah, absolutely. Yeah, so definitely 2006. So we're going to write those as our
It's answer. Like 2007.
I think it's 6 because this is 5. And this is right next to it. Yeah, this is 6.
Okay. Oh, I was talking about 19.
Yeah. Oh yeah, no, I think it's a little bit higher. Yeah, 2006 seems to be higher than the 1997. Yeah. Okay, so the 3 years would be 2006, 2012, and 2015. Okay. All right, and how many degrees above normal? So in 2006, it was about, so this would be 2.5. It was about 2, maybe 2.4 in 2006. It looks like 3.2,
like 2 or 1.
Yeah, and then 2.5. All right, so I'm going to say what did I say? 2.3, 3.2, 2.5 in that order. Wow, I already forgot. 2.3, 3.2, 2.5. Yeah. Okay, so that's what we got. 2006, it was about 2.3 higher. 2012, it was 3.2 higher. In 2015, it was 2.5 higher. Okay. All right, in what 3 years did the US experience the largest amount of land burned from wildfires since 1983?
What was the question again, Mr. G?
In what 3 years did the US experience the largest amount of land burned from wildfires since 1983? It's got to be those same 3 years, right? Right? It should also be those same 3 years. Okay, how much land was burned? How much land was burned in 2006?
About 8 points. 8 points.
Yeah, just over 8 million.
Yeah, 8 points. 8.4.
Yeah.
2006. Yeah, okay. Yeah, I would say about 8.4. I like that. That seems like a good answer. Okay. And then, so 8.4, let me write that down before I forget it, because I will forget it before I go scroll down. So let me 8.4. And then what about in 2012? How much?
11.2.
Okay, 11.2. That looks like a good number. And 2015? What do we see?
Yeah, it's a 9.1 or 8. Is that?
Even just 9, I think.
9.
Right?
Yeah. Okay.
Yeah, just 9. Yeah. Okay. Yeah. All right. So it's gonna be those same 3 years, right? We're gonna say 2006, 2012, and 2015, right? And we're looking at 8.4, 11.2, and 9 million acres were burned. Okay, good. All right, so what we did here, right? We noticed that the whole point of that was for us to be able to see that we can record 2 different kinds of information using the same plot point, right? I used those same 3 years and got the temperature difference from normal, as well as the millions of acres burned, right? So I was able to get both of those things by using the same plot points, okay? All right. All right, and what do you think is going to happen in the future based on what we're seeing in this graph? Is it going to get worse or is it going to get better?
It's going to go.
Based on the graph, it's increasing, so it's going to get worse.
Yeah, based on the graph alone, it's gonna get worse, right? I mean, there are things that we could do, but based on this graph, yeah, I think it's going to get worse, right? It's only getting warmer, so until we make some changes, it's only going to get worse. But yeah, I think based on the graph alone, we're looking at things getting worse. Okay, cool. All right, so we're going to do some reading now, a little bit about how wildfires have kind of gotten out of hand. So we're going to do this reading, and after we're done with this reading, we're actually going to be done with this lesson, because the last thing you guys are going to do, you're going to do it on your own. All right, so let me see if this is, maybe we can make it a little bit bigger. Yeah. All right, we're just going to have each of you read a paragraph just to get us through it. I don't think Toya's microphone was working, because I think she tried to unmute earlier and it was just buzzing. So if the other three ladies would like to read for us, or if we would like to go first, we have these three, we have some paragraphs to go. So who wants to start? The effects of global warming?
She could probably try our space bar, Mr. G.
No, when she did unmute, like because I saw her take the microphone off, and then there was just like loud buzzing noise. So I'm pretty sure.
Even if she used the space bar to temporarily speak, it will give you that noise just the same.
Well, let's try it. Do you want to try it, Toya? You want to try your space bar? See what happens?
Just hold on the space bar and speak.
Yeah, we're not hearing her. I see her doing it, but it's not happening. Yeah. Sorry. Okay, Jennifer, do you want to start us off?
Okay.
Yeah.
The effects of global warming on temperature, precipitation levels, and soil moisture are turning many of our forests into kindling during wildfire season. As the climate warms, moisture and precipitation levels are changing, with wet areas becoming wetter and dry areas becoming drier. Higher spring and summer temperatures and early spring snow melts typically cause soils to be drier for longer, increasing the likelihood of droughts and a longer wildfire season. Particularly in Western United States, these hot, dry conditions also increase the likelihood that once wildfires are started by lightning strikes or human error, they will be more intense and long burning.
Okay, very good. All right, so this word here, kindling is what you need to start a fire, right? Essentially, what they're saying is that we're creating a perfect storm for for fires to get stronger and last longer because of how global warming is changing our forests. Okay, so kindling is like the spark that you need to make a fire, essentially. Well, not the spark, but the materials you need to make a fire are the kindling. Okay, next paragraph. Who wants to go next?
What is the relationship between precipitation patterns, global warming, and wildfires? Mm-hmm. While severe wildfires have been observed to occur more frequently, and this trend is projected to continue throughout the 21st century, it is worth noting that not every year has an equal likelihood of experiencing or droughts of wildfires. Mm-hmm. Natural, I need
cyclical?
Help there.
Cyclical?
Cyclical. Mm-hmm. Natural cyclical weather occurrences, such as El Nino events, also affects the likelihood of wildfires by affecting levels of precipitation and moisture and lead to year-by-year variable in the potential for drought and wildfire regionally. Nonetheless, both temperatures and precipitation levels are projected to alter further over the course of this century. The overall potential for wildfires in the United States, especially the southern states, is likely to increase as well.
Okay. All right. Yeah. So we're seeing that even though things change and like weather cycles are cyclicals, like things happen some years and they don't happen other years, in general, the pattern and what we're creating is increasing for more potential for wildfires, right? Even across the South.
What
All right,
is
so
cyclical?
Cyclical?
Yeah, cyclical.
Yeah, so the word cyclical means that it happens like in a cycle, right? Like,
okay, cycle.
Right, like in a cycle means it is what cyclical means. Yeah, that's a good question.
Cycle, is that what that is? Is it like?
Yeah, so the idea, like, for instance, this past year, we had a lot of hurricanes, right? Even though hurricanes are supposed to happen a certain time of the year, a lot of them happen this year, right? So the cycle is supposed to happen, right? Where you're supposed to have a certain time of year where you have hurricanes, but we're not supposed to have it this intense. So even though it's a natural cycle to have hurricanes, we're not supposed to have them this intensely. So when we say cyclical, it's like something that you expect to happen, right? It's going to happen over and over again. But when it changes or when the pattern becomes more severe, is that we're just saying that, like, it's cyclical, it's going to happen, but it shouldn't be happening this bad. Okay. So that's when we have. Okay, go ahead.
Is that where those graphs that you just showed us come about, where you said this is not a normal graph?
Right, exactly, okay. Right? Yeah, so like you're supposed to be able to predict a pattern in a graph, right? When you can't predict a pattern is because everything is not going according to the plan, right? And so then you have these anomalies, these changes, right? That's what the word anomaly means. Anomaly means a change, like, or a variation of what you're expecting. So if I'm expecting it to be, it's December, I'm expecting it to be a high of 45, and I get a day that is actually a high of 75, that's an anomaly, right? And that's not something I'm supposed to be able to predict. If I get a day that is 22, that's also an anomaly, right? It's not supposed to get that cold. So when we have those changes, right, even though like it's supposed to be getting colder here now at this time, right? It's December. When it gets too cold, that cyclical pattern is thrown off, right? I'm supposed to be in a cycle of cold weather, but not extremely cold weather. I shouldn't have to like be worried about leaving my home. So when we're off of those patterns, that's when we're saying that we create this chance for these destructive events to happen, right? Because they're not supposed to happen. They're not part of what we expect. Okay. All right. So this next section is called a conflagration of cost. A conflagration is a wild, out of control fire, right? So they're saying that these fires are going to cost us a lot of money. All right, Miriam, can you read this paragraph for us?
A conflagration of costs. The economic cost of wildfire can be crippling. Between 2000 and 2009, the property demand damages from wildfire averages 665 million per year. In addition to the property damage, they wildfires cost states and the federal government millions in fire suppression management. The U.S. Forest Service yearly fire suppression costs have exceeded $1 billion at least twice since FY 2000. Don't know what FY means.
Fiscal year.
Mm-hmm. The environmental and health costs of wildfires are also considerable. Not only do wildfires threaten lives directly, but they have the potential to increase local air pollution,
exacerbating
lungs disease and causing breathing difficulty even in healthy individuals.
Good, yes. All right, so fire suppression management is what the government tries to do to make sure that wildfires don't spread or that wildfires are not caused. So when you suppress something, you keep it from not spreading. And when we say that it's exacerbating lung diseases, it means that it's making it worse. So when you have a fire, obviously what's going to happen is that you have a lot of smoke. So if there's somebody who's already sick with a lung problem and now they're being exposed to a fire, right, it's going to make their lung problem worse. And it's also going to give people who didn't have lung problems before lung problems, right? So that's why it's a conflagration of costs, right? So a wildfire is not just a wildfire. It's not just the fact that it's going to destroy a home or destroy a forest. It's all the other things that it's going to cause as well, right? Right, all the underlying health issues that it's going to expose, all these different things. So it's never just about the wildfire. It's always about everything else that it's going to cost us, right? So this should be even more of a reason that our government might want to like invest more in making sure that wildfires don't happen, right? But it also means that they're already spending so much with wildfires. Is why they actually don't have the money to think about suppressing more. They're like, you know how much we're already spending on wildfires? Like, we don't have the money to be spending more. Okay, so that's kind of where we are. Right? It's more and more costs every single year when we think about wildfires and how they're happening. Okay. All right. So what can we do? What can we do to address the threats of wildfires? Well, the global temperature is increasing and the climate is changing due to the greenhouse gas emissions we have already produced, leading to a likely rise in the incidence of wildfires. But it's not too late. What we do now has the power to influence the frequency and severity of these fires and their effects on us. By engaging in mitigation efforts, creating buffer zones between human habitation and susceptible forests, and meeting home and city fire safety standards, and by taking steps to reduce our impact on the climate, we can help to keep our forests, our homes, and our health safe. All right, so this word mitigation means to prevent something from happening in the future. And so if we create a buffer zone, right, this idea of making sure that there is space between where humans are living and the forest that might have a potential to catch on fire will help to reduce the cost of dealing with a wildfire, right? And also by, just making sure that we reduce our effect on climate change in general will help that as well. Okay. So based on what we read, right? So we just read a lot of things. Let's try to answer these questions down here, right? Based on what we read. How does a warmer climate lead to longer and stronger wildfire seasons? How does a warmer climate lead to longer and stronger wildfire seasons?
Okay, because the weather is dry.
Okay.
And the water is dry. The weather is dry, and it makes fire to catch quicker, more. Okay. When it's humid, you don't the fire because things are not dried, so it won't be easy to burn.
Okay.
It's like a fuel. The dry period is like a fuel.
It's a fuel. Okay, very good. Yeah. Anybody want to add anything to that? That's good. Dry weather. Anything else? Perfect. Right. Yeah. So dry weather definitely is gonna make that, like you were saying, right? Dry weather is gonna be the fuel that causes that to happen. Sorry, I'm just trying to move some of my documents around because I can't see.
Leaves are dried as well.
Right. So the warmer climate leads to drier areas. As it's drier, we're going to make things easier to burn. Right. What else with the warmer climate? What else is going to happen if we have a warmer climate?
Drought.
Drought. Okay, good. Yeah, I like that. So dry weather makes fire spread easier, and things catch on fire quicker. It took me a long time to learn that the word on is needed after catch when you say catch something on fire, because where I am from, we say catch fire. We do not have this word on in between.
Oh yeah, catch fire.
But we say catch a fire.
Okay, you guys say catch a fire? Yeah, we just say catch fire.
So, yeah, we too say it will catch fire. Yeah. We're speaking like.
Yeah, apparently catch on fire is the correct English for
catch on fire.
Okay, and droughts, right? Droughts will make fire spread easier as well. Okay, I love it. That works. Other things that were mentioned in here or slightly was about the idea that if the spring and summer are warmer, right, and you have a place where it snows, and we melt all the snow too quickly, then the soil also is too dry too quickly as well, right? Which will also make things dry out and make the fire spread easier. Okay. Although there is an increase in wildfires throughout the century, why don't wildfires always get worse from one year to the next? So this was the paragraph right here, right? That was the second paragraph. Why don't wildfires always get worse from year to year? That was in that second paragraph. What was the reason? What did they say?
Because of the maestro.
Because of the what?
Maestro. M-O-I-S-T-U-R-E.
Oh, the moisture.
Yes.
So moisture might be part of it, yes. But what else is happening? Or what doesn't always happen?
Like drought.
Okay, right. Because weather is cyclical, right?
Yeah, okay.
Not every year, but there's year to year variability, right? So that variability is why the fires don't always increase. Like, yes, we're increasing in general, but you don't see an increase in every single year is because of this variability in our weather, right? So the variability in our weather is why we don't see an increase from year to year.
The variability means because it's time to time. It's not like constant.
The option for change, right, is what variability means, right? Like it's not always going to be the same.
Mm-hmm.
All right, this next question is, the answer for it is going to be in the paragraph, the third paragraph that was read, right? The conflagration of costs. So wildfires don't just affect nature and the natural environment, they also impact people and human communities. In what ways do wildfires impact people?
Okay, it increases their what do you call, health condition, and they lose houses as well.
Yeah, so
homelessness, loss of properties.
Yeah, so one of the things that they mentioned definitely in the paragraph, right? So yes, it's loss of house, right? But always whenever we are, especially on the science GED, and the GED in general, when you respond to a question, don't put in your own interpretation, put in what they provided to you, right? So what was mentioned was the health, right? So
yes.
Negative health outcomes, right? So that's what you can mention, like negative, what we call that, the word that we use is outcome, but you can just say negative health problems for people as well. But negative health outcomes is one of the things that they definitely mentioned in that paragraph, okay? And it says, who and what kinds of communities do you think might be impacted disproportionately? Meaning that which group of people are going to be affected the most by these negative health outcomes?
People that are sick.
Okay.
That has
people that are already sick, right? People.
Yeah, people that has a lung
there it problem. Is. Yeah, people that have lung problems. Right? So you want to mention what exactly was mentioned in the paragraph. Okay, good. All right, and then in the last paragraph, we're going to find our answer to this question. What are some ways people can reduce impacts of wildfires? What are some ways people can reduce the impacts of wildfires?
Create buffer zone between human and the habitation.
Good. Right here, right?
Yes, habitation.
Good. So in general, this is called mitigation effort, right? But if you want to be specific, you can mention a specific mitigation effort right? Or you can just say mitigation efforts, right? But creating buffer zones, right, was one of the things that they mentioned, right? Creating buffer zones, right? In general, this was just called engaging in mitigation efforts. But yes, anything like that, you can mention one of the ways that it can impact, or you can mention more specifically the mitigation efforts, right? The buffer zones, excuse me.
Okay.
All right, so we just did practice 1 together, okay? If you guys didn't do it with me, it's okay. I know that you were here and I know that you did it. So great. Those of you who are watching this video back, please do submit this to get credit for today. Make sure you submit your practice number 1. In your folder as well for this week are a couple other practices. What I would like you guys to do is watch practice number 2. I'm not sure why practice number 3 isn't showing up, but practice number 3 is not required anyway, so it doesn't matter, but I'll add it later and make sure it's showing up for you guys. But practice number 2 is the other part of your video. And this video explains how humans interact with fire. So it's about, I think it's 14 minutes long. So whenever you want to have a chance, you can watch the video and then reflect on how it made you feel and what you learned from the video. I always think it's great to watch these videos and kind of think about other aspects of things that we learned today. And practice 3, which I haven't added yet, is just a story about how we fight wildfires and the money that goes into fighting wildfires. And again, that's just for your information. It's not something that we're going to be quizzed on or anything, but it's always good to get into the practice of doing more reading and reflection writing, because that's what you have to do on the test, right? Is read and write. So I will add that practice as well. I'm not sure why it's not currently showing up. It's probably just hidden for you guys, and I'll make sure I unhide it. Okay. Any questions about anything that we learned today?
Mr. J, I just want to, it's not a question actually, okay. But the assignment that we have, can I complete it tomorrow? No, not tomorrow.
You guys have until
Sunday.
Monday. You have until Monday, yeah.
Yeah, okay, because tomorrow is my son's birthday, and I still have my readings that I missed yesterday because I didn't go to class.
If tomorrow is your son's birthday, then you have to do it tonight.
No, because I have 2 reading and writing to do. I have not done yesterday and today. So by the time I finish the whole thing, can I do it on Sunday?
You guys have until Monday at 3 p.m. You have until Monday at 3 p.m. to do it.
Okay.
Okay, yeah. So that's the new, well, that's my new rule anyway, but I think it's the new rule for most teachers that you have until the next day after class at 3 p.m. to get the work in. So the next day for you guys is Monday, right? Because I'm not checking for your work on Saturday. Sorry.
Okay, thank you so much.
Not doing it.
What is it we're supposed to do now, Mr. J?
The practice number 2, the video.
We're supposed to watch the video, you said?
And reflect on it. So here's the video. You're gonna click this link and then you have to put in this password here to watch it.
And then we answer the questions.
Yeah, it's not really any questions. It's really just how does it make you feel? What did you learn? Kind of thing.
Okay.
Okay, all right, y'all, so that is it. I will see you all next week for our last science class. We're gonna wrap up the semester next week. Have a great weekend. And
all right, thank you. Let me go back to work. Let me go back to my cooking.
Don't burn the pot now.
Yes, Miriam.
Have you ever used the Western Union app? It's not about school.
I've never used that, no.
Yeah, I've used it.
Is it safe?
Yes, it's very safe.
It's absolutely safe. If it's
Western
very
Union,
safe, it's safe. Yeah.
You know, if you have a problem, I'm sorry, Mr. G, sorry to cut you off because I've used it.
No,
so
it's okay. That's why I said it's not a private question.
Yeah.
Yeah. So the thing is that if there